Hello, this is Miss Shane, and we are on lesson 725. This is all about two-column proofs. So far we've done flowchart proofs. Now I'm going to show you another way to write a proof. All right, so we'll start with number 90. This is just kind of a warm-up problem. Which of the following pairs of triangles are not necessarily congruent, even though they may appear to be? So use the following information shown in the diagram to justify why. So on this first one, what I noticed is that the 48 degrees is in between the two given sides, whereas on the right triangle it is not. So I would say that the angles are not in the corresponding spot. All right, and then in part B, if we notice 9 and 9 are equal, but 7 and 6 are not equal. So we would not be able to use side angle side. Those two triangles would not be congruent. All right, number 91. There's a lot of new vocab in here, so we're going to kind of look at the vocab words before we get into the proof. So write a flowchart proof that if a point P on line L is a point on the perpendicular bisector of AB. Perpendicular bisector is just what it sounds like. So this line right here crosses the other line at a 90-degree angle, perpendicular, and it bisects that segment. So it cuts it in half. So that's why they use those tick marks, because that left side is equal to the right side. All right. And equidistant is a new word. Something that you might have heard before might be new to you. So point P is the same distance from points A and B. That's called equidistant. It's just what it sounds like. Equal, distant, distance, equal distance from both points. All right, so now let's go ahead and get into the proof. So what we're trying to prove is that PA, so if we created a line, not a point, a line segment from P to A and a line segment from P to B, then those sides would be equal. I'm going to redo PB because that doesn't look very nice. All right. So I'm going to start this off. I know that AM is equal to MB. And I know that it's given, but it's also coming from bisector, the bisector part of perpendicular bisector. So I'm going to put definition of bisect or bisector. All right, and then something else that I noticed is that the angle on the right side of M is 90 degrees. That means that the angle on the left side should also be 90, since they make a straight line. 90 plus 90 equals 180. Having a hard time drawing that with the PowerPoint. So I'm going to put angle AMP is congruent to angle BMP. All right. And I'm going to put kind of the definition of perpendicular. So if it's perpendicular, both the angles are 90 degrees. There's probably a little bit better way of putting this, but just in simplest terms, definition of perpendicular. All right, and then finally, I know that this side is equal to itself. It's overlapping in both triangles. So I'm going to add in that PM is congruent to PM. Guys, remember, something's equal to itself. We use reflexive property. All right, and now we can say that the two triangles are congruent to each other. So I'm going to use triangle PAM, triangle PAM. I always like to make names if I can. is congruent to triangle PBM. Oops. All right, and then we'll circle that, and we know that by side, angle, side. I'm going to draw my arrows from side, angle, side to triangles congruent. And then we can say that PA is equal to PB. Since we know that the triangles are congruent, the corresponding parts are congruent as well. And that little, the letters that represent that is CPC, TC. All right. And now we're going to take that flowchart proof and put it into a two-column proof. So basically a two-column proof is just a little bit more organized. The left side gives you all the statements of your proof. The right side gives you all the reasons. So we put the if statement is usually, actually it's always what you start with in your proof, your two-column proof. So we put it up here. And that's always our given because that's what's given to us. If you notice, we had angle PMA is equal to angle PMB. They just added in the M for the measure. Measure of angle PMA equals measure of angle PMB, which equals 90 degrees. So they were a little bit more specific than we were. And the reason we know that is because the definition of perpendicular and angles with the same measure are congruent. So you write your statement on the left side, and then the reason for that statement goes on the right. Sorry, I said statement on the left side, reason for the statement on the right side. All right, and then we should be able to fill in a proof like this given a reason or a statement. So we were given the reason definition of bisector. If you remember from our flowchart proof, we wrote that AM equals MB as our statement for that reason. All right, and then PM is equal to itself. The reason for that is always the reflexive property. And finally, we had that PM was equal to itself. No, sorry, they already wrote PM was equal to itself. They have the angles, they have the two sides. So they have side angle, side, just in a different order. So finally, we can write that triangle PAM is equal or congruent to triangle PBM. If you remember, our reasoning was SAS, side angle, sides were congruent. And finally, we can write the given statement. Given statement always goes at the very end. So PA is congruent to PB. And that's because corresponding parts of congruent triangles are congruent.